Hello students, very warm welcome to my YouTube channel once again. So the topic for today's video is structural representation of organic compounds. So this is also a very important topic and questions based on this are always asked in your exam. So there are three ways of structural representation. So first is the complete structural formula, second is condensed structural formula, and third is the bond line structural formula. So one by one I will cover all these three. So first let me start with this complete structural formula. So we can say it is only the expanded way in which we write any structure of organic compound. So here we can see I have written this the structure of ethane. So expanded form means when we write like this. There is a single bond between these two carbon atoms and each carbon atom is attached with the three hydrogen atoms by the single bond. So basically this single bond between carbon and carbon, it is the representation of the two electron covalent bond in this way by writing the single bond. So in the same way, this is the covalent bond between the carbon and hydrogen atom. So in this way we can write the ethane. For writing the ethene, it has to be written like this: C double bond C, and each of the carbon atom is attached with the two hydrogen atom by the single bond. So this is ethene. So next is ethyne. So here we can see carbon are attached with each other with a triple bond, and each of the carbon is attached with one hydrogen atom by the single bond. So this is ethyne. So next I will take about the methanol. So methanol is CH3OH. So in this way it can be written C, which is attached to the three hydrogen atom by the single bond, and then C is attached to the oxygen, and oxygen is attached with the hydrogen by a single bond. And here oxygen is having two lone pair of electrons, which can be shown like this, or simply it can be written like this also. So all these are the complete structural formula which we can say to write the structure in the expanded form. So next is the condensed structural formula. So it is also very simple. We have to write it in the condensed way. Like for ethane, we can write it like this: CH3CH3 or C2H6. So this is ethane. And for ethene, it has to be written like this: CH2 double bond CH2 or simply C2H4. This is ethene. For ethyne, C triple bond C, and here we can write it like this: CH triple bond CH or simply C2H2, which is ethyne. And for methanol, CH3OH, or simply here two lone pairs are shown on the oxygen atom, or simply we can write CH3OH. This is the methanol. So then moving further, the next is the bond line structural formula. So in this bond line structural formula, we can say it is the short and the convenient method to write the formula for any compound. So few key points are there to understand about this bond line structural formula. So first is, in this, carbon and hydrogen atoms are not written. So we will not write carbon and hydrogen atoms in the bond line structural formula. Second is, carbon to carbon bonds are shown by lines drawn in a zigzag fashion. So, the bond between the two carbon atom is shown by a simple line. So, and then if single bond is there, it is shown by this one simple line. If double bond is there, two lines are used to show this double bond, and for triple bond, it is written with the three lines. And then if some other atoms other than the carbon and hydrogen atom are also present, like oxygen, nitrogen, halogen, etc. So they are written as such. So wherever oxygen, nitrogen, halogen are there, they are written as such. And the next is the terminals denote methyl group. Now, so if we see by this example, like this is one example, I have written the one compound with this bond line formula. Simple line is there. So what does it mean? The corner of these, the two corners of this line represent the two carbon atom, like this. So if we write it, so we will write like this. And here, because we know carbon is a tetravalent, it has four valencies. So here we can see one single bond between two carbon atoms. So it is having, we can say it will have here three hydrogen atoms here. It will have, both the carbon will have three hydrogen atoms, then only the valency of this and this carbon is satisfied. So it means that it is this. How we can write this? We can write it like this also, CH3 CH3. So this will be the condensed formula for this compound CH3 CH3. So what is the name for this? This is ethane. So here we can see that the terminals denote methyl group. Like in this case, only simple line was there. So on both the carbon on the ends are the methyl group. So hope it is clear. So then moving on to the next bond line structure. So it is this. So it means that three carbon atoms are present. 1, 2, 3. So let us write this. These three carbon atoms are there. And here we can see this and this are the terminals. So here we can say like this will be the CH3 and this will be also CH3. Both are the methyl groups. And for this carbon, because one single bond, so then it will have CH2. So then only all the four valencies will be satisfied. So what will be the name for this compound? The name will be propane. 3 carbon compound. So the name will be propane. So the next example is this. So here we can see this is having the 3 terminals. Basically this compound is having 3 terminals. One is this one, second is this one, and third is this one. 3 terminals are there. It means that on all the 3 terminals it will have CH3. One CH3 here, here CH3, and here also CH3. And all the other carbon atoms, this one, this one, this one, this one, this one, all will be CH2. All these will be CH2, 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 CH2. So this will be the compound. So we can write the name for this compound. So if we do the numbering from this side, 1, 2, 3, 4, 5, 6, 7, 8. So 8 carbon parent chain is there, and like the 3 position we are having the methyl group. So what will be the name? 3-methyl, 8 carbon parent chain is there, octane. So name will be 3-methyl octane. So this is the name for this. So then next compound, it is this. So here we can see here double bonds are also present. So if we write the condensed form of this compound, so then we can write, because both the ends double bond are there. So how we will write? For here C is here, this C is there, this is C, 1C, this is 1C, and this is 1C. And here is the double bond, and this is another double bond. So this carbon is having this one double bond, so here it will be CH2. This carbon, one double bond, one single bond, it will be CH. This carbon also one double bond, one single bond, so it will also have one H. This carbon, it is having one double bond, so here it will be CH2. So if we do the numbering 1, 2, 3, 4. So name will be 4 carbon atom chain is there. So for this name will be buta 1,3-diene. So in this case name will be buta 1,3-diene. So let us now see this compound. So here the formula structure is given about this organic compound. For this we need to write the bond line formula. So how will we write this? So we see this carbon attached with this and this with this. So to write this chain, we have to write like this. So this is one carbon, this is another carbon, this is here. So, and for these two substituents, it has to be shown like this. This is one substituent and this is the another substituent. So this will be the bond line formula for this compound. And what will be the name for this? 1, 2, 3. Name will be 2,2-dimethyl propane. So for this name will be 2,2-dimethyl propane. So now let us see this example. So here we can see one double bond is there. This is one carbon, this is one carbon, this. So here it will be CH3 and this carbon will have only one H because one double bond, one single bond. Same way, this carbon will have only one H, one double bond, one single bond. This will be CH3. So, name we will write 1, 2, 3, 4. Name will be butene. So, this will be the name for this. Now, let us see this example. So, here this is one functional group is there. So this is C and OOH. So this is the carboxylic acid group is there. And then here this carbon will be CH2. This carbon will be CH2. This will also CH2. This will also CH2. And this will be terminal carbon. This will be CH3. Okay, so numbering, once we do the numbering, so this carbon will get one number, 2, 3, 4, 5, 6. So what will be the name? Hexanoic acid. So this will be the name for this hexanoic acid. So now let us see this example. So for this, one bromine group is present here. So this is the terminal carbon CH3. This will have CH2. This carbon will have one H only. Why? Because 1, 2, 3 single bonds are there. So this will have CH. one H only. This is the terminal one, CH3. So what will be the name? 1, 2. So name will be 2-bromobutane. So this will be the name. So then we can have this another example. Here cyclic compound is there. So we can see these 3 carbon atoms are there. So if we write like this, 3 carbon atoms are there. This carbon is having 2 single bond. So it will be CH2, same with this and same with this. So this for this bond line formula, we can write this structure and the name will be cyclopropane. So this is cyclopropane. So this is the another example where this is the cyclohexane ring is there having 1 chloro group. So we can write it like this. 6 carbon cyclohexane ring. This is cyclohexane ring and this carbon is having 1 Cl. So this carbon will have HC will be CH2, 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 CH2. This is also CH2 and this will have 1 H only. So the name will be chlorocyclohexane. Chlorocyclohexane. So this is all about the structural representation of organic compounds. So I think this bond line structural formula is very important to understand it, and the questions based on this is always asked in your exams. So please understand it and prepare it very well for your exams. So thank you so much. Thank you.